Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss about the topic on model testing of centrifugal pump. So first of all, try to understand what is this model testing of centrifugal pump and why it is required, and what are the formulas will be developed from this. So the model testing is nothing but uh, we know the working principle of centrifugal pump, how it is worked, and what are the applications of centrifugal pump. So we know that the centrifugal pump is used in many areas. Okay, we have seen it. It can be used in the domestic purpose. It can be used for the industrial purpose, and everywhere we can use in the cultivations also. So many applications are there of centrifugal pump. So these are just few things I'm working, just I'm mentioning few applications of this, even uh, you know cultivations, or you can say the farmings. Everywhere we can use this one. Okay, even public space or public you can say that hotels, malls. Okay, so many places it is used. So what I mean to say, when the centrifugal pump is used in domestic or some home or public places, it may be very small size of pump can be used. But when you go for the industrial applications of the centrifugal pump, a large size, okay, a large size of centrifugal pump will be used in that. Okay, so before developing or before going to manufacture this large centrifugal pump, so the when you go for the manufacturing, that means you need to invest many things. Okay, and by that we need to create a centrifugal pump by this manufacturing. So before going to develop the actual to create the actual centrifugal pump, a model can be developed from that. So model is what? Model is the small part of this, dummy part of the actual one. So the model, before going to manufacturing this large centrifugal pump, models can be developed of the centrifugal pump. So model is nothing but this is a small one. Okay, this model centrifugal pump is nothing but this is a small size of centrifugal pump, which is have the similar all these things will be similar to the actual one. So similarity of this model centrifugal pump and the actual centrifugal pump. Okay, the actual centrifugal pump is nothing but we used to call this is a prototype. Okay, so before developing the prototype, the model can be developed. So why you should develop this one? What are the tests we are going to do on this prototype or the actual centrifugal pump? The same test can be conducted or can be done in this model centrifugal pump, so that we can understand okay, if any kind of changes are required or any kind of modifications are required in this centrifugal pump, we can do primarily. So in that way we can save a lot of things. Okay, so and the complete similarities should be there between this model and the actual. So what are the similarities should be there, or what are the similar conditions need to be satisfied between the model and the prototype, that we'll discuss here. So first one, I'll tell about the conditions which need to be satisfied, that is specific speed of the pump. So specific speed, when you talk about the pump, so when you develop a small one, a small centrifugal pump, so the specific speed of the model, it should be equal to, so you can write the specific speed of model, it should be equal to the specific speed of prototype. The specific speed of prototype. Okay, so we have discussed the specific speed this of centrifugal pump in our last video lecture, if you have seen that one. So there we have found just the formula of this specific speed, actually denoted by ns, and for the model we can write this is m, which should be equal to, again we can write this is ns of prototype. And the formula for this is nothing but we have seen in the last video lecture. If you remember, this is n root over of q and divided by hm to the power 3 by 4, and this should be like, this is for, if I consider, this should be for the model, and it should be equal to the for the prototype also. So the prototype formula also will be same. Okay, and we can write the same thing. This is for the prototype. So here n is the speed and q is the discharge, hm is the manometric head. So this is one things we need to satisfy. Okay, and second one we can consider the tangential velocity. So tangential velocity, we know that it is denoted by u, and the tangential velocity, we know that this is u, and the formula of u is, we have seen, that is pi dn by 60. And from this we can write, also here we can write the u is direct, like not from this one, we know that tangential velocity is directly proportional to the hm, which I have told in the last video lecture how it came. Okay, so actually this is nothing but a very simple, we can say that head, the manometric head, we can say this is equal to like u square by 2g or g, or you can say u2 square minus u2 square by 2g minus u1 square by 2g, what we have seen. Now if this is constant term, and this one we can write u equal to root over of h, and we can say that u also directly proportional to this one, hm. Anyway, so this also we have discussed in the last lecture. So here, if u is directly proportional to this dn, I can write, so here I can write u is directly proportional to dn from this one. Again here I have seen that u also directly proportional to root over of hm. So what I can write here, I can write that root over of hm is directly proportional to dn, and from this what I can write, so here also from this I can write this is root over of hm by dn is equal to constant. Okay, so this one we can give equation number 2. Okay, now this is constant. Okay, now what can be find out from here? So find out we can write that model and the prototype. So this one we can write that root over of hm by dn, this is the equation we need to consider for the model. Okay, and it should be equal to like the prototype. So by comparing these two equations, we can find out what are the values are required. This is not whole root over, only root over of denominator will be there. So here we can write again, this is root over of hm by dn, and this is bracket close, here you can write the prototype, and this can be like equation number 3, you can mention it. Okay, so this is the second one what I do, and the third equation we can write in terms of discharge. Okay, so discharge point of view, if you have seen the last one, let me write, suppose third one, the discharge. What is the discharge from a pump? This is also important. So we have seen that the discharge q is q equal to av, and av I have written here area, so that is nothing but pi dB into vf. So here we can see that q is directly proportional to, if you see, d into b into vf. So d diameter and this width b also both are directly proportional to each other. So I can write on place of b I can write d. So we can write this is q directly proportional to like vf. So this is one, and here also like I told you only u is directly proportional to hm. So here vf also there, because tangential velocity and the absolute velocity also both are proportional to each other. So I can write this vf is also proportional to root over of like hm also there, and here if you see vf, let me write here, actually VF is directly proportional to U and directly proportional to this one also. Now E is proportional to, if I dn, if I write, because we have seen U is proportional to this, directly proportional to dn, so I can write VF directly proportional to U directly proportional to dn. So what I'll write here, on place of VF I'll write dn. So what we can write, Q is directly proportional to, this is d square into, on place of VF I can write dn. So what we can write finally, Q is proportional to like dqn. Okay, and finally we can write this is like Q by dqn is equal to constant, and the same constant term I can express in terms of model and prototype. So here also I can express this like dq by dqn for the model, and it should be equal to the prototype. So here also you can mention it like u by dq to the power q3 n, and this will be prototype. So this one again another one equation number 4. Now the next one I can consider for the, suppose now see, specific speed completed, tangential velocity seen, discharge also seen. Now we'll go for the power. What is the power of the pump? So power of the pump, we have seen the formula. This is actually P equal to, we have seen the formula like rho GQ HM. Rho GQ HM, actually that is WHM. So W place I am writing rho GQ, and this is the value we can write, this is this one we can write, and some, if you want to convert into like kilowatt, we can mark it at the 1000. So just I'll write only this much. So now if you see this power term is directly, this is constant term, this is also constant term, correct? Now what are the variables are there? These are the things are there. So what I can write here, that P is directly proportional to Q and HM. Now though I have seen previously Q is directly proportional to this, Q is proportional to dqn. So here if you want to put this value of on place of Q, I can write dqn. So what I'll get here, P is directly proportional to, this is let me write this dqn into HM. So what we can write again, HM place also you can write what is HM, what I have seen here dn. Okay, HM I have seen here dn, correct? So if I write only HM, then I can make it square, HM equal to again directly proportional to d square n square. So here again let me write P directly proportional to, this is dqn, and in place of m I can write this is d square n square. This came from here. And finally I can write this P is directly proportional to d to the power 5 and n to the power q. And so what I can write, this is P by d to the power 5 n to the power q is constant. And finally you can write for the model in the prototype, same thing, like P by d to the power 5 n to the power 3, and this is for the model, will be equal to for the prototype, P by d to the power 5 n to the power 3, and this is for the prototype. So this is another one equation. So these are the conditions need to be satisfied for the model and the prototype. Okay, the similarity properties should be matched. Now the question is, why these things are required for, like if I will go for this, then what will be the benefit, why it is required for us? Okay, yeah, the first one I can say to identify or to verify the performance, of the pump. First one, let me say, to verify the performance of the pump. Like we performance in the sense we can say like to confirm the head, how much head is there, and to confirm the as I told you, these are the parameters need to be satisfied or verified. So we can confirm, we can verify the discharge, and to verify the efficiency, to verify the power between the prototype and the model by the design. So by this, what will happen? If you do these things, then what is the benefit for us? Like what we can get from that? So from this, we can reduce the risk and we can reduce the cost. Okay, we can reduce the risk as well as we can reduce the cost. So why I'm talking about the reducing of cost and reducing of risk and cost. If you go for the full type, like for actual type or the prototype of this centrifugal pump, then the full scale of prototype can be like initially will be huge cost will be there. Suppose any kind of problem happened and that will be not able to rectify and we need to destroy that, so a lot of cost will be affected in that. And so that's so testing and by these models, and we can go for the small one, we can save some cost and also we can check the performance. The next one, this is one point, and see, as I told you already, efficiency. So we can by measuring the efficiency, we can do the energy consumptions also. We can check the energy consumptions. By seeing this performance, we can check the energy consumptions. Okay, and why I'm talking about this one? If you go for the large size of centrifugal pump, so there to develop the more power, obviously input power will be more, and we can say initial level at the model time we can select a small one, a small centrifugal pump which required less power. Okay, and how much output we are getting from the small pump, that can be tested so that we can go for the next one. So by this we can check the energy consumptions. The next one, we can verify the cavitations. If any kind of cavitations formations are there, we can check it the cavitation, and we can also identify, we can study about the cavitations. Okay, so how we can do this one? Actually this cavitation can be identified like by NPSS study. So what is this NPSS? That will study in our next lecture, and the study of cavitation or verify cavitations, that net positive suction head, and also we can find out from the like characteristics of cavitations. So that is another one topic. So this is also will be helpful for us. And the last one, the final one, I can say that we can optimize the design. We can optimize the design. What is the meaning of this optimize of design? Now see, in the pump, if you see, many parts are there, many components are used. So one of the components is, we know that impeller. Okay, impeller is there, and apart from that, casing is there. Okay, in the impeller we know that different kind of like different blades are used here. Different blades in the sense single blade, but it may be different size and shapes are there. So before like to finalize the design, we can change the impellers, the blades shapes and blade angles and sizes of that. So what I mean to say, so these are the things we can do testing in the small centrifugal pump, or that is nothing but in the model before going to the actual prototype. Okay, so this is the difference between the model and the prototype. Okay, and I hope you understand why it is required this model testing of centrifugal pump, to identify these are the parameters. So this is our specific speed of the like model and prototype should be equal. This is the head. From here also you can find out the head. Also again we can find out the diameter of that, and tangential velocity also we can find out. And the next one is nothing but the discharge. From here we can find out the discharge of model and the discharge of the prototype we can identify. And the final one is the power of the pump. So power of the pump also you can find out this will become here. it is out. Okay. I hope you understand this lecture. Still, if you are having any kind of doubt and query regarding this, you can give a comment on the comment box. Thank you all.